Hi, in this video we'll be covering the locus of the line segment. So let's start off with the Argand form or the complex form. What we can do is we can have 2 points, point 1. Let's denote it as Z1, and we'll have that being equal to, let's just choose any point, we'll go 3 plus 2i, and we'll have Z2, second point, and that can be equal to, let's go 5 plus 3i. 5 plus 3i, okay, so we've got these 2 points. Now, we want to try and construct a line segment from these 2 points. So here's what we can do, I'll show you. We can have our locus being equal to z, so our locus is just any number that is on z, and our restrictions for z are equal to z minus z1, so the distance between z and z1, plus the distance between z and z2, difference between z and z2, is equal to the distance between z1 and z2. Okay, let me just note the z's and whatnot, because that makes it a little bit easier to understand what's a z and what's a 2. Don't want to get confused with that. Alright, cool. So we've got this equation here. And let's start just by subbing in our values for z1 and z2, and we can let z equal to x plus yi. X plus yi. Alright, so we have here, x plus yi plus yi minus 3 plus 2i, of that, plus, once again, x plus yi, x plus yi, minus z2, so that's just minus 5 plus 3i, let's put that back in, equals, and we can just kind of figure this one out, z1 minus z2, so that's 3 minus 5 equals negative 2 plus 2 minus 3, negative I. Now what we can do here is we can group, negative 2 minus I. We can group all like terms. So what we can do here in this one is we'll have x minus 3, x minus 3 plus I outside of y minus 2. So I outside of y minus 2. And that plus, and then we're just grouping real and imaginary here. Real and imaginary. X minus 5, because those are the real terms, they don't have i's attached to them. X minus 5 plus I, I want to include the I, just note that's the imaginary part, of y minus 3, always remember your signs, equals negative 2 minus I. Now what does this actually mean? So we can take the modulus of these and work that all out. So what we can do is root of x minus 3, that's a wonky x, let's go a little bit closer, x minus 3 squared plus, and the I disappears, remember, y minus 2 all squared plus square root of, that's a big one, x minus 5 squared plus the imaginary part, y minus 3 squared, 3 squared, and we can actually just work this one out over here. We can have 2 squared plus 1 squared, or negative 2 squared plus negative 1 squared. Either way, it's just root 5. It's just root 5. Okay. Now, what would this actually look like? What we can do is we can find our endpoints. We can prove what points fit onto this equation here, because this is a Cartesian equation for this. So first of all, let's graph this off and just see why this is the rule for this and why this works. So let's make our little eigenplane down here. And we'll plot our 2 points. So imaginary and real. Imaginary, real. Now our 2 points are 3 plus 2i, so that'd be about there. Now we can do 5 plus 3i, about here, something like that. Or maybe not there, maybe something 2 across and 1 up. So maybe like here. There we are. Now, what we can do is we can check what points will work in this and which ones won't. What we can do first is prove why this here equation, what this looks like. So the distance between z and z1, so z and z1, so z is somewhere distance from z1, plus the distance between z and z2 is equal to the distance between them. This just basically means z is any point on this line here. And that's our locus. And how can we prove that this is our locus? Well, let's just take a point on this locus. So we can just take one of our points, z1. We'll take 3 plus 2i and we'll sub them into both. So 3 plus 2i into here would go 3 minus 3 squared equals 0, which would just be cool. Hang on, let's just do this out. Root 0 plus 2i. 2 goes in here. 2 minus 2, 0. So that's just root 0 plus, so 3, 2. 3 minus 5 squared, so 3 minus 5 squared, so we've got 4 here, plus 2 minus 3 squared, plus 1, equals root 5. So it fits this rule. And how can we prove the point, say, out here wouldn't fit this rule? So let's just call this point, say, 1, 1, 2, 1, 2, because point 1, 2. Hang on, let me just get this graph back in the center. It's kind of freaking out on me a bit. 1, 2. And we'll sub 1, 2 into this equation. So what this looks like, sub in 1, 2. Sub into the first part. 1 minus 3 squared equals 4 plus 2 minus 2 squared equals 0 plus, so root 4 plus 1, 2, so we've got 1 minus 4 squared, 1 minus 5 squared equals 4 squared, 16 plus 2 minus 3 squared equals 1. And clearly, root 4 plus root 17 does not equal root 5. Hence why it's not on this line here. So what you can do to figure out what your line would look like, what you can do, sub in your 2 points that you're given, z1 and z2, see if they fit on the line, and if they both do, then that will generally be your line here. And try a point that's outside of that. Try like a real value greater than or less than your lowest or your highest real value. And if that's outside the line, then your line will just be like this, and that is a line segment. We'll be going over more examples of other cases of line segments in our example.